In this video, we're going to go over Section 2, subsets. So let's start off by defining what a subset is. Set A is a subset of set B expressed as A is a subset of B, so that's what that symbol stands for, is a subset. If every element in set A is also an element in set B. So let me show you an example. It's the easiest way to understand this. We're going to let set A equal A, B. Just two elements. We're going to let B equal A, B, C, and D. So what we can say here is A is definitely a subset of B because the elements of A are also in set B. And that's it. That's as hard as it gets. Now, the one thing we do have to remember is this. If we reverse the order, all right, and we ask this question, is set B a subset of A? The answer here is no. And that's because if you look at the elements in set B, A, B, and C, and D, not all of them are in set A. So you'd be missing the C and the D for set A. So reversing the order does not make them equal to each other. Okay? All right. Now, let's go over another example here. Is set A subset of B? And I'm going to go ahead and define them. A is going to equal 1, 2, 3, 4. B is going to equal X such that X equals 2 times N, where N equals 1, 2, and 3. All right. So here I gave you one that deals with a roster method, and then one that deals with the set builder notation. So the first thing we need to figure out then is, what exactly does set B look like? Well, if you look at B, B is telling us that every single element is going to be equal to 2 times N. And I know what N is. N is going to be 1, 2, or 3. So if you think about this, all I'm really asking you to do is just take 2 times 1, which is 2. 2 times 2, which is 4. And then 2 times 3, which is 6. So set B is nothing more than just 2, 4, 6. That's it. So now we can ask our question this. Is set A a subset of B? And according to the definition, all of the elements of A also have to be in B. And that is not the case here. So we just put a line and say, no, it is not a subset. All right. Now, the next thing I want to go over is what we call a proper subset. Now, a proper subset is defined as set A is a proper subset of set B expressed as. Now look at the difference. There's no line underneath this sideways letter U. There's no line underneath it. So that's what makes it a proper subset. So set A is a proper subset of set B expressed as a proper subset B if set A is a subset of B and, so this is the new part, and sets A and B are not equal. Okay? Now we know what equal means. Equal means the same exact elements. Okay? So don't forget that. Equal means same exact elements. Okay? So let's go ahead and let's look at an example. All right? So I'm going to let A equal 2, 4, 6, and 8. All right? And I'm going to let B equal 2, 4. Okay? So is A proper, is A proper subset of B? All right, well, when you look at A, 2, 4, 6, 8, and then you look at B, 2 and 4. All right, remember, in order for this to even work, according to the definition, a proper subset expressed as A subset B. So it says if set A is a subset of B. So you have to meet this condition first. All right, you got to meet that condition first. Well, if you look at what we have, you don't even have a subset. So right there, you stop. Okay? But what if we reverse the orders here? What if I ask this question? Is B a subset of A? Well, we have 2 and 4. And we have 2, 4, 6, 8. And let me zoom out so we can get that definition in here. So when we look at this, do we have a subset? Well, yes. We do have a subset, check. So this first condition, even though all I got to do is just reverse this order. So B is a subset of A, check. Now, and let me reverse this order. Here's where the second part of this statement kicks in. Are sets B and A, are they not equal? Meaning, do they not have the same elements? Well, if you look at 2, 4 and you look at 2, 4, 6, 8, they do not have the same exact elements. B has less. So not only is this a subset, well, we would call this a proper subset. And that's because we satisfied this condition. They are not equal. All right? So you got to be really careful about the definitions. Just make sure you're reading them and you're applying them properly. Now, the next thing I want to do is I want to give you an example on how to find all the subsets of a set. All right? So, for example, let's say I have set A, which is denoted as A, and I want to know how many subsets are there. How many subsets? All right? Well, the first subset will always be the set itself. So our first subset is A, and the second subset will always be the empty set. Now, visually, here's what's happening. Let's pretend this rectangle. Better yet, let's use a circle. Let's pretend this is the Earth. And all the elements on the Earth are just the letter A. That's it. Well, this letter A will be a subset of the world. But then you can also have the situation where there's nothing there as well. And that's why we have two subsets. All right? Now the question becomes, and I'll do this one in this color, how many subsets do we get if we add another element? All right. So how many subsets? Well, remember, you always got 2 right off the start. You have the set itself, and you have the empty set. And then you have 2 more. Remember, you can have the set itself, A, B, but you can also just have the element A. That is a subset. Remember, this is what we're asking. Is A subset of A comma B? Well, remember, all the elements in the first set have to be in the second set. If that is true, then it is a subset. So this is true. So we have a subset. You can also have the element B. So what we've noticed here is this. If you have 2 elements, you have 4 subsets. So I'm going to start writing this information down. 1 element, 2 subsets. 2 elements, 4 subsets. Let's do one more. Let's do this set, and we're going to just add 1 more element. Oops. All right. So now we have 3 elements. Remember, you got 2 right off the start. You have the set itself and the empty set. But now you got to find all the other subsets. So I'm just going to help you with this. In fact, you know what? If you could, maybe pause the video, try to figure them all out yourself, and then unpause and see what you come up with. But here's the answer. We can have the subset A comma B. We can have the subset A comma C. We can have the subset B comma C. We can also have the subset of A, B, and C. So if you were to count these up, if you were to total them up, and I'll just use my highlighter, 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 elements, 8 subsets. And if I just scroll out, you're going to see a pattern developing. Here's the pattern. Notice that as we increase the number of elements by 1, our subsets, ooh, terrible color to highlight that with. Our subsets looks like it doubles every single time, which means we can create a formula. And here's our formula. Let me write it like this. The total number of subsets can be found using the formula 2 to the n, where n equals the number of elements. So if you think about it, with that first example, we just had 1 element. So 2 to the first equals 2. And that's exactly what we found. We found the set itself and the empty set. Then with the second example, we have 2 elements, so we found 4 subsets. With the third example, we have 3 elements, 2 to the third is 8. So we had 8 subsets. So you can use this formula to find the total number of subsets. All right. There is one more formula we can use, and that's this one. To find the total number of proper subsets, we use the formula 2 to the n minus 1, where n equals the number of elements. All right, so let me demonstrate this. I'm going to copy and paste our investigation up here. Oh, didn't want to move it. Nah. There we go. So just let me come down here. Let me paste this real fast. There we go. Now, remember, proper subset means you cannot include this set itself. So for the first one, this set right here, we cannot include that because that's the set itself. So you only have one proper subset. And that would be the empty set. For the second example, you cannot include the set itself, so get rid of it. So now you have 3 elements, or I'm sorry, 3 subsets. So 2 to the n minus 1 equals 2 to the second minus 1, or 4 minus 1 equals 3. And you can clearly see here we have exactly 3 proper subsets. Same thing with C. You have 3 elements. So 2 to the n minus 1, or 2 to the third minus 1, which equals 8 minus 1 equals 7. So we have 7 proper subsets. And which one do we get rid of? The very first one, because you cannot include the set itself for a proper subset. And that's it. So I'll see you in the next video.